In today's class, we will solve a few problem sums based on number systems which are of level 3. The first problem sum says that A, B and C shared a total of rupees 6024. Share of A is 1/3 of the total money and share of B is half of the total money. Find the share of C. To solve this sum, we can apply many approaches. One of them is share of A is how much? Share of A is 1/3 of the total money and share of B is half of the total money. So if we add these two, then we will get the total share by A and B. And if we assume that the total money is 1, though we know the total value, and from the total total value which is 1, if we subtract the share of A and B, then we will get the share of C. So it will be 6 minus 5 divided by 6. That means 1/6 of the total money. And in terms of money, if we want to find, then it will be rupees. Total money is 6024 and this is the part shared by C. So it will be 10, then 6 4s are 24, so 4. So it will be rupees 1004. So this is one of the ways how we can find. And the other way is from the beginning, if we find in terms of money. So total money is 6024, that much rupees. And if we find that how much rupees A gets or how much his share is, then it will be 6024. Then share of A is 1/3. So 1/3 of 6024, then it will be rupees 2008. And share of B then will be rupees 3012. So the share of C, if we want to find now, then it will be from 6024, which is the total money. From that, if we subtract the summation of shares of A and B, finally it will be again 1004 and this much rupees. And now if we want to find that how much that is of the total money, then it will be 1004 and the total amount is 6024. So if we simplify, then it will be finally 1/6. So any of the methods we can apply to get the desired value. Now the next problem sum says the find the greatest possible quantity which can be used to measure exactly the quantities 3 liter to 50 milliliter, 3 liter 500 milliliter and 4 liter. So what we will do first is, here for the first two quantities there are two units, liter and milliliter. So we will first make the units uniform. So what we will do, we will here make all the units in milliliter, and if we do that, then we know, then from liter to milliliter, if we want to convert that unit, then we multiply by 1000. So 3 will be multiplied by 1000, so that will become 3000 milliliter, and with that we will add 250 milliliter. So finally this 3 liter will be 3000 plus 250, so 3250 milliliter. Similarly, so in the first step we have made the units of all the quantities uniform, which is milliliter here, and then we need to find the greatest possible quantity which can be used to measure exactly these quantities. So here we have three quantities, their values are different, but we need to find another value which will be less than these values, but that value can measure all these values completely. That means here this problem is related to division, and we need to find such a value which can divide all these values separately and completely. So if we divide by that value, then there will be no remainder. Now that value can be anything. So we need to find from the values or from all the possible values which will be the greatest possible quantities or greatest possible value. That means Here the concept is we need to find the greatest common divisor, because we are dividing all these quantities. So that value by which we are dividing all these three values, that will be a common value, a common divisor, and we are finding greatest common divisor. So this problem is basically a problem related to highest common factor or greatest common divisor. Now all these three values, if we find the greatest common divisor or HCF, then it will be 2 multiplied by 5 multiplied by 5 multiplied by 5. And for all these 13, 14 and 16, there is no common divisor, so we are not dividing further. So finally the GCD will be 25, then 125 multiplied by 2, it will be 250. Basically you can think that these quantities are oil or water, whatever, they are stored in some container, and there is a small container whose value is, or which can store 250 milliliter of that liquid. So this is the highest common value by which we can measure all these liquids of different quantities completely. The next problem sum says that what is the least positive integer by which 4500 should be divided so that the quotient is a perfect cube. So here this is a problem of a division where 4500 will be divided, so that will be taken as dividend, and the value of least positive integer that we are going to find, by that value we are going to divide 4500. So this value will be taken as divisor, and the quotient, which is supposed to be a perfect cube, that we need to also keep in mind. And we know in case of division, when we multiply divisor and quotient, that gives us the value of the dividend. So to solve this problem or this type of problem, what we can do is we can factorize the value which has been taken as dividend. So first we will factorize this, and then we will see what we can do next. So if we represent the given value, which is 4500, by its prime factors, here we have three prime factors, 2, 3 and 5. And what we can see is 2 is appearing twice, 3 is appearing twice, and 5 is appearing thrice. So this 5 actually can form a cube. So it can be written as 5 cube, and none of the other factors can be represented in terms of its cube value. So we can say that if 4500 is divided by these values which we cannot represent as cube of some value, if we divide by that whole value, whole means the multiplication of all these values or factors, then that value will be basically 5 multiplied by 5 multiplied by 5, and that can be represented as cube value of 5. So our final result or conclusion will be that 4500, if it is divided by 2 multiplied by 2 means 4, then 12 and then 36. So 4500, if we divide by 36, then the quotient will be a perfect cube, and which is the cube of 5. And this is the only possibility that we can see here, that this is the only value 36 by which if we divide 4500, then the quotient will be cube value. But there is another possibility that if we divide 4500 by that value itself, 4500, then the quotient will be 1, and 1 can be represented as a cube of 1 also. So that's why the question has been framed this way, that least positive integer. So here in this case we will have two values. One value is 36, another value is 4500. So among these two values, 36 is the least. Now the next sum says that a total of 1152 students were assembled in rows and columns. If there are n rows and n by 2 columns, then find the number of students in each row. So here the number of rows is n, number of columns is n by 2, and when we will multiply these two values, like if we suppose have 4 number of rows and if we have 2 columns, then how many students we can arrange in 4 rows and 2 columns? It will be total 8 students, right? So how we get this value? when we multiply the number of rows, which is 4, and number of columns, which is 2, then we get the total number of students. Similarly, when it is represented by n and n by 2, then when we will multiply this two value, that value will be equal to the total number of students, which is 1152 as per the question. Now if we simplify this, then it will be n square will be 1152 multiplied by 2. That value will be 2304. So from here, if we take the square root, then it will be root over 2304, and that value will be 48. Now if we factorize 2304 and if we represent by its prime factors, then we can see here that 2 is appearing 8 times. So to get the square root value, we will take half of those factors. So we will consider 4, 2, and we are seeing here that 3 is appearing twice. So we will consider 1. And when we will multiply all these values that I have encircled in red, then we will get 48. 2 2s are 4, 2s are 8, 2s are 16, and 16 3s are 48. The next one and the last one says the LCM of two numbers is 26. Then which of the following can be their HCF? So 26 is their LCM, and if we consider that 1 could be their HCF, we know when we multiply LCM and HCF, that is basically the product of those two numbers. Since HCF is 1, so there is no common factor other than 1 between those two numbers. So one number will be 1 and the other number, if it is 26, and then the HCF value will be 1 and LCM value will be 26. So one possibility is that HCF of those two numbers could be 1. Now if we come to the second option, that LCM value is 26 and HCF value is 2. So there again the multiplication of these two values will be their product, and that will be 52. Now if we say that one of the numbers is 2 and the other number is 26, and if we then find the common factors of these two numbers, then we will divide this by 2. This will be 1, this will be 13. So what is the HCF value? HCF value is 2 and LCM value is 26. That means those two numbers could be, another possibility is those two numbers could be 2 and 26. And when we multiply these two values, that value is 52, that is satisfying. So another possibility is that of those two numbers, the HCF value could be 2, and the third possibility is 13. So here again LCM value is 26 and HCF value, if we consider that that is 13, and if we multiply these two value, then again that will be the product of those two numbers. Now if we take that 13 is one of the numbers and 26 is another number, now if we factorize that, then 13 is the common factor between these two numbers, so it will be 1, it will be 2. So what is the HCF value here? HCF value is 13 and LCM value is 26. And when we multiply 13 and 26, these two numbers, again that is same as the multiplication result of their LCM and HCF value. So what we can conclude is that those two numbers could be 13 and 26, and another possibility of having HCF of those two numbers is 13. So 1, 2 and 13, all these values could be their HCF. So our correct option will be all of this. So this much for today. We will solve a few more problem sums in the next class. Till then, stay safe and stay healthy.